All right, welcome back to the stream. So today we're going to be working on some sprite sheet stuff. So yesterday we've got this going for us, right? So we are able to populate all of the tiles with a quad of our choosing, and then we're able to modify the corners. So that's not quite good enough. And I see our stream is very slow. Let's hope that gets better. Yeah, we're sitting at 2,000 kilobits a second. I'm hoping that gets a little more stable here. Okay. So, if we take a look at how we're rendering this, we're doing this right now. We're going through every column, actually every row, and then for every column, we're going to be inserting a key value pair into our tiles. So this line here gives us an empty table in every row, right? And then this one gives us, we're inserting a table of key value pair here. So we're saying ID gets 9th, and we're inserting that into tiles at the y-th position. So what that allows us to do is change this to be 8th. If we change this to 8th, we've got all our 8s. So that allows us to change everything, and then here we're manually changing the corner pieces. So today's goal is to have complete control over what quad we're rendering here. Because right now it's just in a for loop, and we can just choose whatever number we want. But we want to have more control. We want to be able to put, pavement in the middle, sand down at the bottom, grass up here, whatever that turns out to be for our level design. We want to have that complete control. And then bonus, we want to actually be able to do, we want more than that. We want to be able to draw multiple levels. And AKA Bob, I went live 3 minutes ago, but my thing was super laggy. So it's still pretty laggy. So hopefully that's not too awful. So we've got all our 8s here. So today we're going to be working on getting more control over that. So, if we wanted, and here we're just plugging in a value from our constants. So it's really simple right now. 5 stands in for 5th, 6 for 6th, all that stuff. So if we put in 5th, it treats it as 5, and it draws a tile ID of 5. So let's get going. So instead of doing this, we don't want to draw the same tile for every single frame. So I'm going to comment this out. Now, what I do want to do, there's a couple ways of going about this. Now, all we really have to do is set the tile, right? So like our table tiles is a 2D array. So just like how we're setting up the top left corner right now, we do a 2D array 1, 1, that's going to be our top left, and we say its ID field gets the tile code for whatever we want. So if we want that to be the first, we can hard code it like that. But it's not so pretty to just hard code everything like that, right? So we can go about this a couple different ways, and what we can do is do a little loop, so that instead of hard coding in the 1, let's say we do it for every row. So 1 would be the first row, the top row, and then X would be every subsequent column. If we do it like this, if we do it in a for loop, right? So we can say for X gets 1, for as long as our map width, which is going to be 10 in our case, do this. And what we're going to do is assign our tile ID for the first row only, though. So, and this, if we do this, let's see what happens if we do this, right? It doesn't like it. Now, I think, let's see if we put in just 1 here. Okay. Now, we aren't giving ourselves the tiles table here. So we do need to give ourselves the tiles table. We have an empty table here, but we can't index into it. So we'd have to give ourselves an empty table. And then we need multiple. Okay, so I guess what we would need to do here is make sure we have and this is the hard thing with Lua. Lua's will crash if you try to index something nil. So let's get rid of this and let's try to do 1 row worth. So we're gonna give ourselves a table. It's gonna be first, second, all the way through 10, right? So third, fourth. And then we have a 9 by 9, so we don't actually have a 10th, so we'll just put 9th. And then now this is a row 1. So row 1 is a table that we can index into that can give us so the problem here is we've got an empty table here, but we need to tell the table that every index holds a thing that can hold a tile ID. So that's why we were crashing. So I think what we can do here is, I think we've got to, we could either do it like this, where we could say tiles, tiles at index 1. Well, and I like the, let's do it here. For X gets 1 for our map width. So we're going to do something a column amount of times. And what we're going to do is just insert an empty table into our tiles master table, right? So you say insert into our tiles table, and we give it an empty table. So it seems like that isn't doing anything, but it allows us to not crash. Because once we try to assign an ID, it doesn't know how to pair the ID with what tile unless we give it a little container to put it in. So what we can do here is now we can go through our row. So we say for X is 1 for our map width, and we try this again, but this time we're assigning our row. And this is just for demonstration purposes. Like if we hard code in that first row, but then we give ourselves the column of whatever our X is, and we assign that ID field to be equal to something, right? And if we do this, you know what? Yeah, if we turn this on, we don't actually have to do what we just did. Let's do that. We'll turn this off for now because we're doing it up here. So we're populating everything with 5, and then we're trying to just change the top row. So we're going to be trying to just change the top row here. So if we assign first into our ID, hopefully all top row is 1, which it is. So that's kind of useful, right? So we could say any number here, third, and now we have access to just one whole row instead of all of the squares, right? So, and this isn't what we want either. Like, it is readable, right? In the sense that we can put, instead of putting the hard-coded constant here, what we can do, we can get a little creative with it, and we can put in from our row 1 table that we assigned 2 lines above, we can say, you know what, at our xth index, go ahead and put that value. So it should put first, then second, then third, then fourth, and fifth into each column. And look at that. We've got, so like, this is the basis of what I've been wanting, is I want to just visually script out, you know, grass, water, edge grass, whatever it is, and visually script it out, and then just have it, boom, save it. So that's getting us close. So just to kind of show you, we can change, you know, this one could be 8th instead. So like it can go 8th, 4th. And then if we save that and run it, it goes 8, 4. So we have full control over that top row now, which is great, but it's still not what we want. We want, sorry for the lagginess, guys. I mean, it says I'm at 6 megabits a second, which you would think is good enough for 30 frames a second, but it's really hiccuping. I don't know if I should stop the stream and restart my modem or what, because it's pretty bad, right? It's not freezing? Okay. If it's not freezing, I guess we could go. It's just sad that it's so freaking bad. It looks so... OBS is telling me it's 2 megabits now, so whatever. If it gets worse, let me know, chat, and I'll restart my modem or whatever. So we've got full control over this top row, which is nice. But what would be really nice is if we have full control over all of the tiles, right? For all 10 by 8. So let's see if we can't figure that out. Now, instead of doing this stuff, because with this method, what we'd have to do is say, okay, well now there's row 2, row 3, row 4, row 5, row 6, row 7, row 8. And then we'd have to do this as well, where we would say, okay, well that's the first row, second row, third row, fourth row, fifth row, and then that's just looking messy, right? Like it is nice that if you look at a glance there, that the table is in that kind of square where it's 10 wide and 8 down. So it'll make visual scripting or visual assignment of our sprites a lot easier. But I don't like the messiness of all this stuff. So and these would have to be hard coded, you know, for whatever column we happen to be rendering or whatever. So let's do something different here. So we're gonna delete that, and what we're gonna do instead is we're gonna try to, I guess, do a 3-dimensional array. So we need a 3-dimensional array because we need at least a 2-dimensional array because we need the row and column of what tile to draw. But we need a 3-dimensional array because we want to do different maps depending on what quadrant you're standing on, because once you walk around, it'll render different sprites, right? So we want a way to say, hey, if I'm in quadrant 1, 1 or whatever on the global map, render this sprite sheet. And if I walk up, I'm going to be 1 row higher, but this whole different sprite sheet. So we've got this. I think I'm going to turn this off because we want to do something similar. but it's going to be trickier because of the three-dimensional array. So I imagine if we're walking around, we want to have access to whatever grid we are in the overworld, because if you think about one whole screen as being one grid on our whole overworld, we need to be able to keep track of what index that grid is. So when we walk or when other people walk, we know, oh, he's coming from the right side, so that's one column over in the positive. So we'll need to keep track of our current grid, I guess current X grid, right? So let's just give ourselves 1 for now, I guess. So current X grid, current Y grid. So we'll be at 1, 1. In reality, we want to figure out how many quads, how many spaces of walking we can have, and then make our hometown or whatever we start in, either in the middle or at the very bottom or something like that. But for right now, we're just 1, 1. And it's going to be... We also need a map to store all the three-dimensional arrays. So we're going to say map gets an empty table. And we're going to populate that with all our data. So we've got our empty map. And we're going to... there's no way to kind of... I'm not sure of a way to kind of dynamically allocate room for a bunch of stuff, right? So like, I guess for now, we'll just do for X gets 1, comma, 5, we'll just put 5 empty tables into our map. So we have, at least right now, a potential of 5 different grids we can put in. So we're going to give our map table as the first argument, and then the value as the second argument. We're just putting an empty table in our map. Okay. Then I guess what we want to do is we want to start to populate our maps table at whatever our current grid is. So if we're rendering our current grid, it should go Y then X, because Y is the row and X is every column for the row. So we'll say map at current Y grid and current X grid will now get assigned to be an empty table, because we have to be able to hold a tile ID inside this two-dimensional array. So we'll give ourselves that empty table, and then what we can do is, I guess we don't have to initialize it empty. We could just initialize it straight up, but I'm going to keep it like that because we want to test other potential grids. So we're going to go reassign what we just did, and we're going to say that this now gets a table, and for the table, this is where we're going to put all of our tile key codes, whatever we call them, tile IDs. So for right now, for illustrative purposes, let's do the 1st through 9th, which we deleted it. We deleted the one we already typed out, so we have to do it again, sorry. Okay, 1st, 2nd. So we need 10 across, and then ultimately 8 down. So 7th, 8th, 9th, and then 9th again. Now we need a comma at the end of this. So if that's our first row, there's our 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th. So that should be all the values we need to do a whole map, what we're calling it, a map. And it's a map at our current X grid, current Y grid. We can change these names. I'm just trying to get it down first. So what we have to do now is we have to go again and we have to put in an empty table for our tile, because if we take a look at how we're rendering this, we're rendering it right here with a tile ID. So quads takes in a tile ID. So what is a tile? Well, a tile is a location of from our tiles table. So tile is just what we're calling the tile ID that we're storing in our tiles table for every single grid, basically, or not grid, but what do you want to call it? For every sprite, every 16 by 16. What do we call it? So let's go render this. Not render this. Let's go put in our tiles. So we're going to do something a map height amount of times. And what we're going to do is right here give us table.insert into our tiles table. We should have this already. I don't think we commented this out. We should have a table called tiles, which we do have. I'm just going to put it down here with this so we can see that we've got it. So tiles is an empty table. Now what table.insert does is it doesn't remove anything. It just pre-appends an empty table to this list in this instance. So for every row of our map height, we're just going to give ourselves a tile, an empty table for us to do some stuff with. So we're going to say for x gets 1, map width, we're going to do, here's where we need to assign the ID into that tile. So table.insert, and we're giving us not just tiles, our table, but tiles at our y position. Now what that means is since we're inserting, this is going through row by row, and it's going to go prepend every tile into this row. So tiles 1 will be every top row, tiles 2 will be every second row. And then what we want to do is give it the ID that we want, the tile ID. So we're going to say that ID gets, we want to assign into this the value of each row, right? So like if you look at this 2D array, map current Y grid, current X grid, this is the first value. So this is 1, this is 2, this is 3. So by the time it gets here, this is 11, this is 12, this is 13. So by the end of all this, it's 80. So index 80 will be here. Yo, Fart Knocker in the house. What's up, dude? So what we're trying to do is insert into our tiles ID. So here's where it gets interesting, where it's like we want to put a tile ID into every value of, actually we want to take every value from our grid that we just declared up here. So how do we get a value from this 2D array? Well, we have to index into it. So if we want the first value, it's going to be the first. So now since this is doing the whole map, it's doing all of the rows and all of the columns, then we actually want to keep track of one variable and keep it growing, so that by the time we're on the second row, it's actually 11, index 11. Third row is going to be 21. So if we just pass in a variable called count here, we need to initialize this. So as long as we increment our count variable, then this will continue to go up. Let me give us a count variable here, I guess right here. We'll just say count gets 1. And then we want to increment the count, but we don't want to increment the count inside our tile set, our tile insert. We don't want to do it there, because if we do it in there, we're going to draw all the same. We're going to draw, I guess. Yeah, I think we want to increment it outside that that insert, because we don't want to. If we put it inside, if we put it inside here, what this is doing, this is inside a table. So first of all, this would just crash because we don't have a comma here for this other key value pair. But we're not trying to set a key value pair for the tile. We're trying to keep track of a global variable. So we want to increment it out here. And then I think that's all we need to put in every one of these values into our map table. So, I heard the new Fargo is really good. Is it? So far, I loved the first couple seasons were awesome. Okay, so instead of doing this old stuff, actually, what's great is we can still keep this, because all we're doing is drawing all of our tiles. We're using that same tile table to render. Yeah, I know they start off so strong, and they're not afraid to just take wild chances. So I really like that about Fargo. I think we might be. You know what? Let's see if we crash, because we should have put in all of our map, but yeah, okay. Because the tile ID we're putting in is from this map, so we should have all our values we need. 64, we crashed. Count gets count plus 1. So what did we do wrong here? Oh, we need to close our table.insert function. Okay, so check that out. We've got that whole map of values. So if we go ahead, let's try to change some stuff here. So like let's say we change fourth with ninth, and then we change. Let's change ninth with sixth, just to change some values here to see if it's working. We just changed some values around, and look at that. We've got some random 9s in there. I don't see the 6s. We put in 6. Oh, we didn't save it, that's why. So we can substitute 9th or 6th globally, and then save it. And there's our 6s. So now we should have a full way of drawing these different quads. So I guess let's try to do just like a little shape to make it clear that we're drawing one level, and then I'm going to try to draw a different level so that we can compare it. Because the power of this is hopefully that we can change multiple maps. And then once we have the capability to save multiple maps, We just have to build it out in level design and kind of figure out what of our sprite sheets can go where. So if we put in, I'm putting in first on all the top values here. So we should have ones all the way across the top. Okay, so this is what we'll call level 1 for now. So the goal is hopefully we can make another level with different values and switch between them as we want, right? So I guess the way to do that would be that this would be hard coded or something. So we can say, hey, this is gonna be, let's just call it 3-3. So like if we had like a bigger map, then 3-3 is what we're going to be calling this quadrant of whatever this level is with the first. So we would want to put in this, I guess this is the value that matters for which one we're actually going to draw. So if we put in 3-3 here, I'm hoping we get the same level. Okay, cool. So now the question is, can we take this and this as sort of our template for a whole, what do we want to call like one whole screen worth of stuff? I guess just map at index. I don't know. But like, let's say that actually the one right past it at 3-4, so the same row, but one column to the right. So if we walk from left to right into this one, we're going to change all of these into 2. So let's go substitute first for second, and we'll do that globally, and we'll save it. And then when we go to insert it, let's say, okay, we're not trying to render that first level, we're trying to render the one next to it. And we got level 2. That's exactly what I wanted. You know, we're in business, guys. Grid. Yeah, you know, grid is exactly what I called my 2D array when I built my board game. So it makes sense. So yeah, we'll call it at the 3-4 grid of our map. Does that make sense? So yeah, so map at our 3-4 grid is this level 2, and if we shift it just by 1, we get our level 1 again. So we're in business. This is what I wanted. So what's so great is now we have like a visual representation of how to render these sprites. So once we add in a huge sprite sheet with a bunch of different sprites, we would still need that storyboard that you called it, Fartknocker. We still need that storyboard so that we can say when we're assigning in our constants, like, oh hey, which sprite is this? You know, 130,000 pixels down and 20,000 pixels right. What is that? So we can save that as sand. We can use that Colton-Ogden function for Python to slice up and storyboard our massive sprite sheet so that we can assign it in our constants as a certain number. You know, sand gets whatever, and then we'll be able to visually map it out here. And if we have, I wonder if we can put, I'm gonna put some spaces in here and see if it still interprets without crashing. It does. So I guess by the time we have the full names of all of our sprites, of all of our tile IDs, we don't know exactly what they're going to be called. So like some are going to be called, you know, we're going to have like sand or water or bottom left BL grass and call it like BL grass for bottom left corner. Something like that. So it's like I'm trying to figure out what the longest one might be. You know, have like brick. We might have post. I don't know. We might have flower. We might have. So whatever our longest word is. So like let's say it's bottom left corner grass. That is what, 9 or 10 characters long. Then we can go into our play state here, and we would just give an equal amount of space for all of these. So like whatever our longest one is, we can kind of standardize it so that everything lines up perfectly for our grid. So we can see like, hey, when we do this, we want this to be grass. We want it to be left edge grass. So it gets left edge grass. And we know right beneath it, we want it to be another left edge grass. So we would say left edge grass like this. And then, you know, once everything is nice and tidy up, we'll be able to kind of visually script our levels just like this, you know? So we can see, oh, this one right below it, instead of all the offset, you know, because this is getting messy. We have to know like diagonally is right beneath it. So this is going to be super helpful for us. This is going to be so helpful. And this is what we need to start our main sprite sheet now, because now we can actually render things without having to manually place every single one. This is so nice. So yeah, I think if we just put grass in there, yeah, grass is just one, I think, or, well, let's see, because I think grass is saved as well. Well, that's why. We crashed because grass isn't even saved in here. So, okay, so for next episode, we're gonna be working on, we got to do a couple of things. Like, I'm gonna just undo all of this so we can just render it again. Let's just render the second level again. So ideally we kind of we'd have like a constance of yeah, exactly. We're gonna make a big old reference sprite sheet. And we're gonna just have that with the number of what quad index it is just saved in here with this, so that we don't have to dig around. So what I might do tomorrow is download that big old sprite sheet of the Link overworld and just try to figure out how to use Colton Ogden's function on how to splice it and put the storyboard numbers on there. And if I can figure that out, then we can use that for our own sprite sheet once we build that out. Then we just have to decide all the pieces of our sprite sheet. And if we build it out with a set resolution, and we only build it out, you know, top first, working our way down, then none of those indexes should change as long as we keep adding to it instead of mixing them around in order for it to make sense. We just need to add them, and then that's where they live, unless we want to go digging around and changing all the numbers. So that's going to be really fun. I'm super glad we've got this, because this is, and if you aren't so sure what we're doing right now, it's just to give you guys an idea. We're taking this picture, it's one picture, and we're going over that one picture. It's a one picture called 9 circles, and it's that small. And we're taking that and we're splicing it up into the individual circles, and then we're telling every single quadrant for the sprites here what value that picture gets. So we're using only one PNG file to render all these different pieces all in the right place. So that's huge. That's huge. So the next big step is we got to figure out how to scroll the screen to the next level once we walk over to it. So like if this is level 2, level 1 is to the left of us. So we have to initiate a screen transition that not only renders everything that's currently on our screen off, but everything that's about to be on our screen on in a smooth transition, and then update our player to be the appropriate other side of the screen. And then hopefully we don't lose any frames in there, because you know, we're gonna have to figure out how to do that. There is a Zelda level on the Game Dev CS50 tutorial that I wonder if we can just take a look at that. That might be fun to take a look at on stream. Let's see if we can pull up that real quick. So CS50 Game Dev, what's it called? Now there's a repo for it. GitHub CS50, what is it called? Games 50, that's what it is. So yeah, we'll do some fancy fade in transitions and everything. We'll get to it. So let's go ahead and nab this repo here. So it is a games50 zelda.git. So yeah, let's just do games50 zelda.git. We could just do it right here in our terminal. So what we're gonna do, and this is in NeoVim, so we'd want to go out of NeoVim. Okay, man, what do you want from me? Right here, we'll do a git clone, and we'll go https://github.com/games50/zelda.git, and we'll go clone that bad boy. Now we'll cd into our Zelda folder, which why didn't it let us do that? Okay, and we'll try to run it. Check it out. Okay, so in this one, we've got a button. Now watch the screen transition here. See that crap? So that's exactly what we're trying to do. So we want to draw all the stuff that was on our screen, just move it. See, because even all the entities are still there. So all the entities that were on screen are still there, and then every entity that's gonna be on screen is also still there. So that's gonna be really big if we can figure that out. So I'm curious, we're in the Zelda repo now. Let's just see how they went about it. We won't be able to implement it today probably, but maybe we can figure out how they're doing that translation. See, this is smart. This is really smart to give animation a class, because then we can set the amount of frames, set the timer, set the current frame, and then we don't have to go for this whole interval and timer increment for every single thing we want to animate. We just assign it an animation class. So we'll probably do that at some point. Where would it be? Play state? Game play state, maybe? So like, where would that transition be? Is when we're rendering it? Maybe we could transition? No. Translate? I don't know. It might be in the dungeon, wherever the dungeon. Oh, dungeon. It might be here. Oh, look it. camera X and shifting. So look, love.graphics translates values when shifting screens. So how are we doing this? They're doing, it's a state machine they're using. So they're saying, or yeah, I've never done this. This is like an event.on. I've never used that, but it's almost like a state machine. But what's happening is saying, hey, once we're a shift left state, then we're gonna be this function called begin shifting, and it's gonna translate by a negative virtual width and a 0. So, and here's what it is. So shift X is that first argument, shift Y is the second. Oh my gosh, yeah, look at this. So it's like they take the adjacent offset X of the next room. So they have to assign the next room. Shift X, okay. Oh, there's a lot of crap going on here. I guess I'm not seeing where... Oh. Come on, translate. It's got to be translate, right? Okay, it's in the render. There it is, translate. Okay, so they are doing a love.graphics translate with this camera X and camera Y value. So, oh, that's a good idea, Fartknocker. Yeah, that's a good idea. And like, so I am thinking of, so Fartknocker asked if we're gonna add a run function so you can like go faster through a swamp or something. That could be really cool. You know, I mean, I'm thinking of like Pokemon Gold and Silver where you can get a bike and then, you know, traverse like that. And then in Ruby and Sapphire, you can do bunny hops. There's no bikes in this world, but oh, you know what? There are horses. There's a horse. Maybe at one point you get a horse and then maybe you can run at the cost of some stamina, you know. How original is that? But I guess I'm curious. I'm curious to try this graphics.translate. Translate the camera we're shifting. So see how they're rendering both. Okay, so I'm gonna check when they do this next room. Is it under the begins transition? Because they set it to nil here. And then yes, when they begin shifting, then they give themselves a next room. So it looks like they're rendering. If you look at this, it looks like, you know, we're rendering the current room and we're rendering the next room, all in every frame. But we're only rendering the next room if there is a next room. So there becomes a next room once the transition begins. So that you're only defaulting to rendering that current room, and then if you're transitioning, then go ahead and render the current room plus the next room. So this is tough because let me just see what this love.graphics translate kind of does. So translate the camera if we're actively shifting. So let's just give ourselves. Let's take a look at their camera X and camera Y and see what they're doing. So they start out as 0, and then it gets tweened by a shift X. Is tween a function that comes with Lua here? I've never seen that before. I should have finished the class. I did Flappy Bird and I was like, I'm making Joust, and then and then it took me 2 years to make Joust, and now I'm here. Okay. Shift X. Let's see what Shift X is, and they're setting. I'm just trying to get an idea of what they're doing with the translate. Okay, Shift X isn't, it looks like it's just an X position of the next room. and then they kind of slowly move it into place. Okay, so you know what? Let's do. Let's go back into our Kavoth project. So, actually, I could have just. No. Let me see. I thought I'd be able to just harpoon over there. Oh, it's because I'm in a different directory. Okay. So, let's go into our Kavoth, and we'll go into here where we can harpoon. Now, let's see in our play state if we can see what that translate does. So let's give ourselves the same variable, camera X, and we'll set it equal to 0. And what we'll do is in our update function, we'll say camera X gets updated by itself -1. And then what we'll do is render, actually, and this is what I don't get about love.graphics.translate is it translate everything that's being rendered? I don't get what love.graphics.translate. That's what it was, right? Now, I was hoping our LSP would have some info on it, but if we put in our camera X and then we give it a translate of 0 on the Y, does this do anything? Oh, did you see that? It did. It moved our one thing. Let me see if we put it up here. Oh my god. So I guess if we put it before everything, it'll translate everything. Oh. Yes. I know, yeah. I wish I was exposed to coding in high school. I would have loved to build something like this. This is awesome. Okay. Wow. Okay, so we literally just have to do something like they did, which is, you know, we have to keep track of our next room like they do, but our next grid, right? Sorry for the crappy stream, guys. I'm gonna try to fix that. All we gotta do is keep track of our current room and our next room, and then we only render the next room if we're transitioning, and once we're done transitioning, we stop rendering that old room. And we only need to begin transitioning if we interact with the proper side. So it's going to be a couple-fold problem. It's like we need to detect which side we're going on. Then we need to detect if that's a legal move. Excuse me, if that's a legal move, like, you know, if there's actually a place to be up there. And then we can translate like this. So for right now, I'm gonna comment that out. And what we'll do is we'll just call it a night here. Let's take a look at our git diff. Sorry for the crappy stream, y'all. So we really just implemented our new tile system for rendering our maps. That's really nice. In the next episode, I'll experiment with that slicing and see how that goes for our storyboard, and then we might be making sprites tomorrow, or we might be doing some more transition stuff like this. So scene transition stuff or sprite stuff kind of depends on how much energy I have tomorrow, I think. But I am going to try to talk to Xfinity about getting better internet, because I'd love to stream this in 60 frames a second for you guys, because 30 just isn't really cutting it when we're playing with our game, you know. So I'll see if I can get faster upload speed and then maybe get a hardwired internet connection going, because I would really like to stream in 60 FPS, full HD, boys. Anyways, thanks for watching, guys. We'll call it a day. We'll get add everything, and we'll say watching. We'll say added map render. Added map sprite render for entire grids, and then we'll get push that bad boy. Okay. So yeah, thanks for watching, guys. I'm gonna see if we can raid my friend Practical NPC, because he is live. So if you guys don't mind, if you guys want to hang out just a tiny bit, and you can raid Practical NPC and just say what's up and say cool game, that would be really cool. So I'm gonna raid out, and I'll catch you guys later. Thanks for watching.